Hello grade 9, here is our video lesson for quadratic functions. So quadratic functions are functions that can be described by equations of the form f of x or function of x equals y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a, the coefficient of x squared, cannot be equal to 0. Otherwise, if a becomes 0, then our function is no longer quadratic one, but it is only a linear function. So the highest power of the independent variable is 2. As you can see in our general term or general form, ax squared is the highest power. So what is the difference between a quadratic function and a quadratic equation? So for a quadratic function, it starts with f of x or function of x equals ax squared or the quadratic term plus bx plus c. So this is the general form of the quadratic function, while a quadratic equation has only ax squared plus bx plus c is equal to 0. Okay, so this is only quadratic equation. So in short, a quadratic function is equal to ax squared plus bx plus c equals a dependent variable f of x or simply y, while a quadratic equation is ax squared plus bx plus c, the general form, equals 0. Here are examples of equations of quadratic functions. Y equals x squared plus 3x minus 2. So here is the quadratic term, the linear term, minus 2, and y is the dependent variable. Y represents f of x. F of x or y, they are just synonymous, or they just have the same meaning. Another, 0 equals 9 minus y minus x squared is also a quadratic function, because if we simplify this by transposing y or negative y to the other side of the equation, we get y equals negative x squared. We have to rearrange the terms such that the first term is the quadratic term and to be followed by linear term, and the last term, which is the constant term. But in this case, we don't have a linear term, so the constant or the quadratic term is to be followed immediately by the constant term, which is positive y. So we have y equals negative x squared plus 9 is the quadratic function. Another, f of x equals x squared minus 4, or function of x equals x squared minus 4. Also, y equals x minus 4 quantity times quantity x plus 2. So this is a quadratic function because although it doesn't have a quadratic term as it seems, but if we multiply the binomials by applying FOIL or first outer inner last method, we have x times x, which is x squared, and x times 2, so that's positive 2x, Negative 4 times x, that's negative 4x, and negative 4 times 2, that's negative 8. So we have y equals x squared minus 2x minus 8. So this is the quadratic function from or as the result of simplifying our original function y equals quantity x minus 4 times quantity x plus 2. Now, how can we determine if a table of values is a table of a quadratic functions? So, take note that in the quadratic function, equal differences in x produce equal second differences in y. So, you have to check first if the x's have equal differences, and consequently the y's or the values of y have or produce equal second differences. So for example, this letter A here, table A. So if we subtract the y's, 2 minus 1 is 1, 1 minus 0 is 1, so 0 minus negative 1 is still 1, and if we continue the process, still negative 1 minus negative 2 is 1. So the x's have equal differences. Now let's proceed to our y values. If the second differences are equal, then the table is a quadratic function. Otherwise, if the first differences are equal, then the table is for a linear function only. Look at this. 19 minus 16 is 3. Then 16 minus 13 is 3. Then 13 minus 10 is still 3. And 10 minus 7 is also 3. So the first differences are already equal. So this is a table of a linear function and not a quadratic function. Now let's try the second table or table B. So let's check the values of x first if they have a uniform differences. So let's say 2 minus 1 is 1 and 1 minus 0 is still 1. 0 minus negative 1 is 1 and 0 minus negative 2 is also 1. And for the values of y, we subtract 13 minus 8 is 5. Then 8 minus 5 is 3. Then 5 minus 4 is 1. And 4 minus 5 is negative 1. So notice that on the first differences, uh, there are no equal uh, results. And if we continue subtracting for the second differences, we have 5 minus 3 is 2, 3 minus 1 is 2, and 1 minus negative 1 is also 2. So since the the second differences in y are all equal, then this is a quadratic function. So this table is a table of quadratic function. Okay, another example. Which of the two tables is a quadratic function? Let's check. So you subtract 20 minus 17 is 3. 17 minus 14 is 3. 14 minus 11 is 3. And 11 minus 8 is 3. So the first differences are already equal. So this is not a quadratic function, but it's obviously a linear function. Now let's check if the second table, or table letter D, is a quadratic function. Subtract 33 minus 16, that's 17. 16 minus 5, that's 11. 5 minus 0, and that is 5. And 0 minus 1, that's negative 1. Continue the subtraction on the second level. 17 minus 11, that is 6. 11 minus 5, 6. 5 minus 1, or minus negative 1, still, that is 6. So since the second differences are equal, then this is a quadratic function.